we've got a few more people in the room from when I last polled. Has anyone here used mobile services before? One person. So this is, I'm not sure if you've watched any of the content I've presented before at different places, but this is an overview session. In actual fact, it looks like I've got the wrong map on there. So apologies about that, that must have been North America. But this session's an overview, so it's sort of level 200, 50% deck, 50% code. Following this in Central C, the next slot in Central C will be a deeper dive where we'll go a lot further than what you'll see here. So just a FYI, if you know mobile services, then this one is probably basic for you. All right, I think once everyone gets settled, we'll get started here. So just a bit of background from me. It's great to be home. I've been exiled to an office in Redmond for the best part of 2.5 years. So it's always nice to come back home and present to some fellow countrymen. So today we're going to talk about developing connected Windows Store apps with Windows Azure mobile services. This is an overview session. We're going to do 50% deck, 50% code, but it should give you a good idea of what mobile services is and how you can sort of start to use that in your applications. So here's the agenda. We're going to deal with or talk about what is mobile services. We're going to look at what data storage mechanisms it provides you. We're going to look at push notifications for lighting up your start screen. We're going to look at security and authentication, and also the built-in scheduler and scaling functionality. Then there'll be some Q&A time there as well. So I'll give these guys a second. Welcome. All right. So that's the agenda: data, push, scheduler, scaling, and auth. So what is mobile services? So mobile services is a turnkey backend solution that we provide within Windows Azure for your mobile applications. So basically what it provides is it provides a number of different scenarios to your apps that can go out and sort of consume this service and do things like store data, send push notifications, so they're like your toasts and tile updates if we're talking about Windows Phone or Windows Store apps, or if you're talking about Android and iOS, we also support those client applications, and we've got client SDKs for that as well, and we also support sending push to those platforms through APNS and GCM. Provides an auth layer, so you can lock down your tables such that only authenticated users can consume the data or push data up. We provide server scripts. Server scripts essentially allow you to execute code on the server side to do things like data validation, cleansing, really anything that you want to write, you can do it there. Scale, like everything in Azure, we provide built-in scaling support. So, if you launch your application and it's perhaps, not popular to start with, but you start getting a lot of downloads, a lot of users, it's as easy as dragging a little slider to scale out, and that takes all of about 5 seconds to add instances to your deployment. We provide logging and diagnostics functionality baked into the mobile services. Helps for debugging things really, for the most part. And the last thing that we've got here is the scheduler. So scheduler allows you to basically execute script on a timed basis. And we'll see that one today as well. So let's do the, I guess, the most basic demo that we've got, which is getting started. So it's a good place to start, I guess. Let's go to my demo machine here. All right. So this is the Windows Azure portal. Who's used Windows Azure before in any type of capacity? All right. So this is the Windows Azure portal. Mobile services is one of the options here, and this is what we'll be playing with today. To create a mobile service, it's quite straightforward. I've got a few here already, but we're going to create a new one. Hit New, Mobile Service, Create. And then this essentially identifies your mobile service. It's the subdomain name for your mobile service that's addressable on the internet. So let's say that's, what do you guys want to call this? Hey, Amin. What would, Amin? Okay. All right. Someone's already taken it, sorry, man. There you go, put a K on the end. So what we've got here is we've gone and we found an available subdomain, and now we can choose to use a DB. Now, you have to use a database here. That's for persisting all your data, obviously. But there's two options here. You can start with a free DB. It's just 20 megs, but it's a good way to sort of kick the tires without any cost for your databases. Those of you with MSDN subscriptions, you probably already have free DB built into that. So I'm going to say create a new database. Currently, we're deployed in these 4 regions: East and West US, North Europe, and East Asia. So I'm going to go to East Asia. Now that's sort of your web tier. Now this configuration here is your data tier. So our DB is going to be called Amink DB, and we're going to co-locate our DB with our web tier in East Asia. So if I say, put in my server password here, you can see on the left that we've got SQL databases there. It's not really too clear. Let me click on this. We've got SQL databases. So this is Windows Azure SQL DB. It's basically the same as SQL Server on-prem. There's a few small sort of things that are different, but for the most part, it's identical. And that's where our data is going to be stored. So what's happening now is this is the sort of turnkey thing that we're talking about. Windows Azure is going off and spinning up a brand new mobile service for us that's addressable at amink.azure-mobile.net. So let's give this a second to create. It normally takes about 20 seconds or so, which is realistically pretty good for what you're getting out of the box. Any questions this far? Quiet room. Amin, do you have any questions today? All the time? All right. Let's see how this goes. Always a little nervous standing around waiting for this to happen. There it is. All right. So now that's up and running, we can click into it. Now this is basically what we call the quick start page. It provides quick starts for a number of platforms. So these are the client platforms that we support for mobile services. We support Windows Store apps, Windows Phone 8 apps, iOS apps, Android apps, and we've basically got a HTML/JS library that you can use within, say, a website if you wanted to use it in a website, or an Apache Cordova app. You can use that there. So what we'll do here is let's download the Windows Phone version of the Quick Start here, and we'll do the Windows Store one as well. So what we've got here are two options, really. If you've already got an existing application, you can grab this code and drop it in, and you can start talking to your mobile service. We'll review the code of this in a bit, but what we're going to do today is download sort of a pre-packaged demo application, and I'll show you how that works, and then we'll build out on that for the rest of this scenario today. The first thing you need is Visual Studio Express 2012. The next thing we're doing here is creating a table. So this table is going to be called to-do item, and that's where all of our data is going to be stored. The last thing that we need to do here is to download this Quick Start. Let me save this somewhere. No. Just put it here. Name it Windows Phone. Okay. Let's download the Windows Store one as well. just download this here. Okay. Now, let's have a quick look at this table. Data tab here, you can see that's the to-do table that we created with that quick link. And if we click into it, there's no data, there's just an ID column. That's it. And then from this, we're going to see how we can go and populate essentially the schema dynamically through mobile services. If you wanted to create new tables, it's as simple as hitting create there. We'll do that a bit later on as well. So let's jump in. Let's go here. And let's extract. There's the Windows Phone one. And I downloaded the Windows Store one to the wrong place. And we'll drop it there. Okay. So we've got that and this. All right. So let's open the Windows Store. Let's open the Windows Phone. There we go. And we'll spin these up, we'll run it, we'll look at what the app does, and then we'll drop into the code base to see how it's actually working. So this is the Windows Store app. I want to kick off the phone emulator here in the background. Free target to 8.1. I'm using 2013. That's a problem. Not so much, but open with. There we go. A little bit slow off the mark today. It's the jet lag. It's like 9 p.m. back home. Open with, and that. There we go. Okay. So this is the. It's hard to tell. There we go. That's the Windows Phone one. Let's spin that up. Let's spin up the Windows Store one as well. Come on, Nick, you can do it. There we go. Okay. We'll start with Store, and then we'll go to Phone. We'll have a race to see which one gets there first. There we go. Okay, there it is. So this is a simple to-do list application. Basically, it's provided there out of the box to allow you to go and see how the CRUD operations work within mobile services. So on the left here, we can add items. So hello world. And then we can say add another. Now, in the time that I've hit save to when you see it on the right there, that's actually gone and persisted that up within our mobile service and also queried that data back down. You can see that we can do things like perform updates as well. So that was basically an insert operation. That's an update operation that I did when I'm checking these guys. Let's add another one there. And we've got a query operation here as well. So let's jump to Windows Phone here for a little bit. And let's hit refresh on this guy. And you can see that both these client applications now are consuming the same service backend. And really, there's not much code to it. We'll have a look at that in a second. Before we do that, I want to show you the data. So if I click over here on the Data tab, go into to-do item, drag this guy out like this, move this guy across, you can see that there's our data. We've got a couple completed items, and we've also got an item that's not complete. Adding another item as well from phone, save, hit refresh. You can see it's really quite simple to go and start using this to store any of your entities that you'd like. So I really want to show you the code for this because that's the most important part. So let's jump into it. The first thing that it's done, or that's basically baked into this package, is a reference to the Windows Azure Mobile Services SDK. Now this is a NuGet package, so you can go and drop this NuGet package into your existing solutions. Just going manage NuGet packages and searching for Windows Azure Mobile Services. Now, this client SDK allows us to go and consume our mobile service. So the first thing that you need to be able to do that is what we call the mobile services client. So an instance of this basically is your client proxy to your mobile service. You can see that it's pointing there at a min.k.azuremobile.net. and we're using what's called an application key here to somewhat secure requests against that service. So with this now, we can actually start performing those CRUD operations. So let's have a look at how those applications did that. The first thing that we've got here is our to-do item. So this is our entity that we're persisting up to Windows Azure. You can see it's got an ID property there. That's the primary key. And we've got text and complete properties there. The JSON property attribute on top of those basically just specifies the way you want that property serialized. So in this case, we're using lowercase t and c. So if I come back to the portal, you'll remember that when we were looking at this to start with, there was no columns in this. There was just the ID column. So I haven't had to go and execute any SQL or deal with my database at all. Mobile Services has done what we call dynamic schematization, where we go and inspect that entity. We look at what properties it has as it's pushed up, and we look at the types of those properties and determine, what's the best way to go and persist that data within the DB, and we scaffold those columns for you. So with that, let's jump back here. So that's our entity that's being passed up. So we've got mobile service collection here, which is just the collection that's bound to the UI. To go and work with your tables, it's simply going app.mobileservice. That's our instance that we've defined here. Then we say get table, and we pass in the actual type that we want to interact with. So in this case, we're working with the to-do item table. And as we come down here, you can see now our insert operation simply calls to-do table, insert async, and it passes an entity. So it's one line of code really to persist your data up to your mobile service. And that's one thing that we've really tried to make extremely easy for people, is that communications with your servers is going to be very, very short in terms of the amount of code you need to write. You don't need to know about HTTP client or HTTP web request or any of that sort of stuff. You simply just call a simple CRUD operation on the client. So that's an insert. This is an update. So this is update, and again, we just pass in an item. Delete is also supported. Delete async. And of course, to get your data back, you can query your data. So in this case, we're calling, this was the refresh button. When we click that, we're saying to-do table.where, and then we provide an expression. And in this case, this is our filter. So we're saying send me back only items where complete is false. And it's that easy to perform your CRUD against a mobile service. So that's basically the getting started demo. So let's jump back here to PowerPoint and keep going. So let's talk a little bit about how that data was stored. So under the hood, it's powered by a Windows Azure SQL database. Now, there was an option there to say, do you want a new DB? Do you want a 20 meg DB? Or do you want to use an existing database? So if you have, say, 10 mobile services, you can have all 10 of those mobile services pointing at the one database. So that's really a cost saving for you. The way we go and partition that data out, such that mobile service called app X and mobile service called app Y can't sort of read that data, and there's no collisions in terms of table naming, is we just prefix it with a schema. So if we had two apps pointing at our DB, it would be appx.todoitem and appy.todoitem. Now, a lot of people ask, hey, this is really cool, okay, you can store the data, but maybe I actually want to get in and start using, I want to execute some T-SQL commands, I want to, maybe add a stored procedure or something like that. You're not locked out of the DB, you've got full access to it. You can manage it in a number of ways. You can manage the data within the Windows Azure portal. So on the data tab there, we could have hit truncate to basically flush all the data from that table. You can use the SQL portal or SQL Management Studio. Who uses SQL Management Studio here? Who tried the SQL portal before? Keep your hand up if you liked it. One guy? Okay. I prefer SQL Management Studio personally, but basically the point I'm making here is you can use the tools that you're most comfortable with. So, when we spun up that mobile service, what did it do? And what was that API that we were consuming? How did it look? So, this is the REST API for mobile services. For your tables, everything's under WAC tables. And you can see that we've got the HTTP verbs post, get, patch, and delete supported there. You can see on the read operation there, the query is converted into an OData filter. Now, it's good to know that this exists. You can sort of use it if you're using perhaps a client platform or language where we don't already have a client SDK. So you could go and call the REST API directly. I built a .NET Micro framework client SDK just using this. But for the most part, the client platforms you'll be developing on, we've got client SDKs for them, as you saw in the portal. So how's that dynamic schematization work? And what is the type mapping today for those types that are being passed up? So when you say insert an item, it serializes that item into JSON, and then mobile services will inspect those entities as they come up, and it'll say, is it numeric of any of those types, and the underlying T-SQL column will be, in that case, float with a precision of 53. Boolean goes to bit, date time to date time offset, and string to and varchar max. So we just saw sort of the data side of things, but it was straight pass-through. What happens in most web apps that you're building, right? If you're building a client app with a web backend, typically you want to do some kind of business logic on the server side, right? With mobile services, we provide a thing called server scripts. And this is basically your way to execute your business logic on the server side before that item is persisted. Or even if you're reading back or updating or deleting, so any of those REST operations. So what happens here is the server script is actually Node.js script. Intercepts CRUD requests to tables, say that really fast. By default, it's a straight pass-through to SQL. It's fully customizable in terms of how you have that code execute. So if you wanted, you could basically not save to SQL. You could use the Azure Node SDK, and you could go and perhaps write your data to table storage if you prefer to do that. So node modules. So the server script, as you're authoring it, basically you're going to want helper libraries, right, to go off and do some common things. So if you want to send email, out of the box, your mobile service already has SendGrid, a node module for SendGrid installed. We've got the push.star namespace. We'll talk about that a bit later, but that's for sending push notifications. If you want your server script to perform an outbound HTTP request, perhaps you want to call a service that's running on-prem or something like that, or call a third-party service like perhaps a blog RSS feed or anything like that, you can use the request module. We've got console, that's for basically diagnostics or logging. MS SQL if you want to execute raw SQL statements. Pusher, that's basically like a socket-based, event-driven module there that allows you to basically push data in, and any clients listening to it will receive that data within a matter of seconds. Sort of cool if you want live graphing or that sort of thing. The micro framework solution I built, it was collecting sensor data, pushing that in as an insert to my mobile service, and then I was using Pusher in a server-side script to actually send that sensor data out to a website that was live plotting that data. So you can do some cool things with these. Status codes, they're the standard HTTP status codes. Azure Node SDK, use that if you want to use things like notification hubs, table storage, blob storage, Windows Azure queues, and a whole bunch of other things. Twilio's in there as well, so if you want to send an SMS on any of those CRUD operations from your server-side scripts, you can do that as well. We'll see a couple of these today. But let's jump in and see how you can actually add the server script to perform some simple validation. So I'm going to go to script here. So just so you know where we are, we're on the data tab. Click into the particular table that you want to work with. Select script. Hopefully the network's good. There we go. And you can see this is where you can author your script. So you've got each of those CRUD operations available, and you can write script for each of those directly here within the portal. If you come to the session directly following this, I'll show you how you can use source control, so you're not editing script and saving it live, and I'll also show you the new tooling built into VS 2013 for working with your mobile services directly from VS. But for the intro session, we're just going to use the portal because developers across any device platform all have a web browser, right? So let's have a look at this. We've got an item. That's the item being pushed in to be persisted. We'll look at user in a bit. That's for authentication. We've got request, and that's the request that's sort of coming in. Request.execute essentially persists that item to the DB. So if I want to do things like, say, if item.text was one of the properties, if the length of it is less than 5, perhaps this validation says request.respond, and we'll say status codes.bad request. And we can say text is too short. Now, the IntelliSense in here today is not awesome. It's sort of okay. Let me show you this. So you've got some IntelliSense here. We're working on it. It will get better. There's a whole bunch of reference documentation online if you want to see what the APIs are and what the functions are. So we're going to say, if the text is too short, we're going to say, sorry, it's a bad request, and we're not going to save the item. If the text is long enough, then we're just going to simply execute the insert operation. So we'll save that. And once that's saved, it's actually live. So I'm going to switch back to the app here. We'll insert 5 first, so this should insert. And now if we go back and say, well, let's insert something less than 5, you can see that we've got our text back here, and it's thrown a mobile service invalid operation exception. So you can handle in the client side those exceptions and perhaps bubble that up to provide some kind of nice UI around validation. So always good to validate on client and server. That was a very simple script. We'll see some more advanced ones as we proceed through today and this afternoon's session. So that was server script. What have I got for you next here? That is interesting. There we go. Auth. So those operations we were executing there were using an application key. But that app key was stored basically in the code on the client side, right? So if people really wanted to reverse engineer your app and find that app key, then go and use it for something that you probably don't want them to do, that's possible. So we provide a few other options for authenticating the users of your applications and locking down the actual data and CRUD operations to them. So out of the box, we support Microsoft account, Facebook, Google, and Twitter. In terms of permissions, we can actually, on those CRUD operations on your table, you can go and lock down individually those operations to have a permission set. You could say everyone. Perhaps you want everyone to be able to read data out of your service. Anyone with an app key, which is what's on by default, which we've already seen. Only authenticated users, that maps to anyone who's logged in with one of these identity providers, and only scripts and admins. That's basically only server-side script can perhaps execute that, or only someone who has the master key, which is another key set for your mobile service. So that's out of the box. It's configurable with drop-downs. I'll give you a demo of that. But if you want more granular control, within your server scripts, the user object has a level and user ID. So you can go and build out your own authorization policies on top of that to perhaps add more control as to perhaps only an admin can read certain subsets of the data out, or you might want to add a filter for their data specifically, say with the user ID. So let's jump in to the portal here and do a demo of that auth. So I'm going to click back out. Any questions so far? It's a very quiet room. Normally I have people throwing things at me. Okay, just after lunch. Yeah.
So we have like our existing database and our existing business model.
Yep. The client-side code, you mean? Your server-side code. So your yeah. Yeah. Yeah, yeah. So you can. So when you say reuse your code, at the moment the portal only supports Node.js scripts in the back end. But in terms of your existing schema, etc., yes, you could use that, and you could basically query off to any table within that server script using the MS SQL object. So if you wanted to query, a table, you're inserting the say to-do table, you may want to query your user profile or user account table and do something there. It's certainly all possible. Pardon? So, yeah. Yep. Yeah. So basically, you could, if you've got forms-based authentication or something like that, you can basically write your own code to support that provider. And yes, you could call the stored procedures or anything like that to perform the validation. There's a few good blogs on it. So you're not locked into just Microsoft account, Facebook, Twitter, and Google. It's fully extensible however you want in terms of that auth scenario. Yep. What language would you like to see? Okay. Anyone, who else wants C#? Me too. Yeah, we've certainly heard that feedback, and it's something we're sort of investigating and looking at how to do that well. Okay, so let's jump into this. So we're in the Identity tab now, and you can see we've got Microsoft account, Facebook, Twitter, and Google as options here. We'll get into the configuration of that in a second. The first thing I want to do is actually restrict the permission set on my table. So I select permissions. You can see here, they're the options that we just discussed. And for insert, I want only authenticated users, maybe on all of them, only authenticated users. So if my app is still running, maybe. If my app's still running here, if I try and now save something, we should get an unauthorized exception. Yep.
Would you need to configure that permission per table?
Yes. Yeah, it's per table. It's not across the whole service. We've got what are called the CLI tools, which allow you to basically go off and automate this sort of thing if you wanted to. So you don't have to go into the portal to do it. This, I think the debugger had detached from the last instance of this or something, but you can see now that that's a query where it's trying to get the list of existing data, and it's unauthorized. So that's how simple it is to lock down the permission set on your particular table. Let's go and see how we can actually authenticate a user. So we've spent a lot of time essentially making the workflow for configuring authentication really, really easy. So if I go to the Twitter developer portal, we're going to use Twitter as our auth. We can come and simply create a new application. We'll call it a Mink. A Mins mobile service. Shameless plug. Did you guys see that? Come down a bit further. This bit's important, callback URL. So the authentication flow here needs to eventually redirect back to our mobile service. And we need to provide our mobile service endpoint. Let's drop that in. Come down. Capture control is always hard. CANK771. What's that? Did I spell? No R. Ah, thanks. Someone's awake. There we go. So with that, our Twitter app's basically created. Now we just need to configure our mobile service and provide a login experience for the client app. So we need the consumer key. Let me pull this across here. Jump into identity. Scroll. There we go. So consumer key, consumer secret. And with that, our mobile service is now configured to allow authentication from Twitter. If you went and configured apps in Microsoft account, Google, etc., you can utilize all of those. So you could provide the user an experience whereby they see, do you want to log in with Twitter, Facebook, Microsoft account, etc., and then they just choose what they want. We're just going to do one today. So that's Twitter, and if we jump back, let me close that one, this guy too. So if we jump back here now, stop the app, we can actually write some code to authenticate the user. So I'm going to just put it in on navigated 2 here, and it's going to be async. Whoa. And then we just simply say await app.mobileservice, that's our mobile service client, login async, and we use the mobile, whoa. What shortcut was that one? There we go. Mobile service authentication provider enum, and you can see there that basically you can choose which one you want. So if you were supporting multiple, you'd be calling into this and have a switch statement, on the back of the buttons or something like that. Let's get rid of this. There we go. So with that, that's our authentication done. Hit run. And you can see now that we're presented with essentially the web authentication broker for those Windows Store devs, but we've gone and wrapped that into a simple one-line method to go and do this. So you can see that my credentials are cached using the Windows Password Vault. Hit Authorize App. Now I'm authorized, the query will succeed, and now my application is secured for only authenticated users. So that's auth. Any questions before we move on? Pretty easy, right? Has anyone actually tried to implement the sort of Twitter OAuth flow? Sort of take crazy. There was 2 questions here. Pardon? Yeah. Yep. Yeah, so you can use ACS or Windows Azure AD if you wanted to say authenticate, a corporate account. That's certainly possible. It is a bit of code. We're working on expanding the set that we provide out of the box, but there's other providers that already do this for us. Like there's a company called Auth0, and Auth0 basically provide a broker for you to go and authenticate with any of those, plus a whole bunch of other identity providers, which is pretty cool, but certainly extensible for you to write it on your own, and eventually we'll sort of catch up and provide a lot more. Just depends on how soon you guys want C# support, I guess. Yep. Like ZAML? It's been a while since I've dug into the auth flow of mobile services. I'd need to look at that. Yeah, so you can certainly use ACS, but I think we're using just a simple J token or something like that. Is that right? What's it called? I'll look into it after it come up, and I'll find that for you. Let's start on push notifications here. I think I'm sort of going a lot slower than normal. Okay, push notifications. Who has seen a live tile update or a toast message on any of your phones or Windows Store apps? Okay, that's good. Some of you have. The rest of you are asleep. This is how they work. So on the left here, we have a Windows Store application, and it's basically the same for iOS, Android, Windows Phone. There's a few little things that are different around auth, etc. But in the general sense, this is how it works. Windows Store app on the left, on the right are our services. Everything that's blue, we need to code. Everything that's green is provided out of the box. We just need to know how to talk to it through either APIs or whatnot. So let's look at the workflow. First thing that you do when you want to send a push notification from your app is request a channel. This is basically a unique identifier that can be used to direct a notification to that particular app instance or tile. So we do that in the notification client platform of Windows. It's just a simple WinRT API. Once we get that channel, we pass it off to our cloud service, in this case, our mobile service. It could be a web API if you're working with web API on-prem or on some other host. But your service typically needs to know that channel and who that channel is for, such that it can make informed decisions as to when to push to that particular user. Let's say if it's a weather service and I'm interested in the weather in Redmond, which is always basically raining, what would happen is that channel would go there with some metadata where I'd say, I'm interested in Redmond. At some point in time, your service is going to be, say, polling some National Weather Bureau to get a weather update. And it'll say, OK, give me all the channels for all the users that are interested in Redmond. And it will then compose a notification, authenticate against, in this case, the Windows push notification service, and send an XML payload that defines, say, that tile update or toast. So we authenticate and push. The Windows push notification service will deal with delivering that notification and surfacing it to your start screen. So in mobile services, how do we do this? We provide a simple API called push. The star can be APNS, WNS, MPNS, or GCM, depending on what platform you want to push to. In the WNS namespace, we support tile, toast, badge, and raw notifications. The portal captures your credentials. That's part of the configured auth flow for WNS. So there's a page there which we'll look at. And then you can simply call really nice and easy to use methods that will go and generate XML payloads for you. You don't need to know about the XML that defines a tile update anymore with this. Has anyone actually dealt with that before, like constructing? Yeah. So it's it's a little bit. Yeah. Yep. Yep. Yeah, so push.wns has basically, you'll see the APIs in a bit. There's nice methods if you want to send one or the other. If you want to send both, you need to then just send the XML that defines both. If you want to only make one HTTP request outbound. Otherwise, you can just make 2 requests out. Yep, yep. So that's certainly possible. Yep. Yes. We've got what's called custom API now, which basically provides script that will execute that's not attached to a CRUD operation. And I'll demonstrate that in the next session later this afternoon. But yeah, basically you could have that call in, pass in parameters and such. There's custom API. I'm going to have to jump into this demo, but shoot out the question while I switch here, and I'll try to answer while I do. Yeah. Yeah, so we've got a new service which we recently released called Notification Hubs that does provide an abstraction on top of all those platforms. It also provides a really easy way to scale out your push to millions and millions of devices without actually having to write that scaling code yourself. You can. Notification Hubs, there's a module for it. It's actually within the Azure SDK. I'll have to jump into this demo because it's actually sort of 15 minutes long and we've got a few bits to get through, but we'll jump into question time at the end here. Okay, so we want to send notifications, right? Who watched the build keynote, day 2 keynote at all? Anyone? Okay, so we've got some really cool tooling in VS 2013. I'll show that to you in the next session. In VS 2012, there's a lot of manual steps here to do that push notification workflow. And it's really important to understand that as a fundamental sort of foundation before you get like really nice wizards that do it for you. So we're going to essentially do the whole thing. So the first thing that we need to do is we need to actually, request our channel. So within my app here on launched, I'm going to drop in some code that will request the channel. I'll drop it in here. I'm going to use some snippets. And let me resolve these here, and then we'll walk through this piece of code. Okay. So the first thing we do is we call into this WinRT API in the windows.networking.pushNotification namespace. It's called the Push Notification Channel Manager. Now, the Push Notification Channel Manager has an operation here saying create push notification channel for application async. Does anyone think that is the longest method name in the entire API? Does anyone know a longer one? No? There is. Hold on, let's do that. Secondary tile async. So that's if you want to have multiple tiles pinned to your start screen in this case. So that returns back a channel, which is essentially a URI. Now what I'm doing here is creating a channel DTO. Now this channel DTO is essentially what I'm using to persist that channel into my mobile service. So the first thing I do here is when I new it up, I say, well, this is executing every time the application launches. I don't want to insert duplicates of this channel, so I want to be able to track the ID I'm storing on the server side. And the first time, if there's no ID, we just perform an insert. When that ID comes back, we store that. And then next time the app runs, we actually perform an update. So I'm using local settings in this case to just sort of persist that ID for multiple app starts. So we take the channel URI, we take the expiration time, which is another reason why you need to request a new channel basically every time the app starts, because they do expire. It's normally about 30 days, but sometimes if we're under sort of any type of load or there's a reason, WNS may actually go off and purge some of those channels in very rare cases. So we say if there's a channel ID or if there's no channel ID, let's perform a simple insert of our channel DTO and then store the ID that's returned. Else, let's call update async, and I'll just perform an update. So that's step one. Now, step two was to save that to our server, which we're doing here, but we need to actually define a table. So dynamic schema only does columns. It doesn't go and create new tables for you. So in this case, we have to create a table called channel. We're just going to leave it to anyone with the application key in this case. We could say restrict by user if we wanted to. Less drop downs for me to play with though. And in doing this, we just get a simple empty table with an ID column. And that's done. So that will provide us somewhere to store our channel. The next thing that we need to do is to configure our client app with the credentials required to form the appropriate auth handshake with WNS. So we can do that. We've got something nice built in here that we say right-click, store, associate app with the store. Hit next. I can't really remember. I think that's right. Yep. So what this does is now it pulls all my apps down that I've got in the store. If you want to reserve one, you can basically hit this. I'll go out to the store and you can provide your own app name. I'm just going to probably choose, it's Wednesday, but Tuesday works, TechEd 2013. Hit next. That's going to go and update my AppX manifest with these particular credentials. So that's done. Now, I did open up the portal here for a specific reason. So this is the Windows Dev Center. It's basically where you go to upload your apps when you're ready to publish them in the store. What we need to do is we need to configure our mobile service now to have what's called the client secret and package SID, which is like the server component of that auth credential required to send push. So we configured using TechEd 2013. So if I click into this, you'll see under services, we've got push notifications. So we can click in here, click 100 different things, and eventually you get to what's called the Live Connect portal. And that wizard which we executed from the client side identified our app, and now we need to authenticate our service. So we need these two credentials for that. If I come back to my mobile service, select push, you can see Windows application credentials go here. No space on the end. There's our package SID. If you're dealing with APNS, you can upload your cert. Any Apple devs here? Okay, you can stay. And Google Cloud Messaging, you can put your app key here as well. Basically, the push tab is where you configure all of that. So let's save that. So now we've requested our channel. We've registered that with our service. We provided a table for it to be stored in. We've configured all the keys required for auth. Now all we really need to do is write that code that's going to send our push notification, right? So what I'm going to do is I'm going to jump into the to-do item table here. It's an easy place to basically have something execute. And we're just going to hijack this insert operation to do a toast notification in this case. There we go. So let's have a look at this. The form is a little different. So what I do in this case is on insert, I execute the request, so it's going to save my item. And then I say, on success of that save to the DB, respond to the client app so it can continue, and then send a notification, and I pass in the item. So this is what's called the tables module, and you can use that if you don't want to execute sort of raw SQL. So in this case, I'm saying, get a handle to the channel table, read it, and that's going to just try and read all the results there. And then on success, pass in the result set, named channels in this case, and iterate through those. Now, for each of the channels it finds in that table, I'm going to use the simple API that we provide here to send a notification. So push.wns, in this case, we're sending a toast image and text 03. So that is basically the template that we're going to use. So let's say toast image text 03. That's not good. It's trying to go co-op. There we go. Can you do it? There we go. Let's see here. Let's say tile template enum. Better. That's for tiles, and there should be a link to toast here. So I really wanted to just point this out to you guys because it's quite useful, the documentation on MSDN here. There's a picture basically of what the different templates are. So you can see we were doing a toast image text 03. So our notification will look basically like this. What is it? It's image, 2 lines of text. And regular text on the third line. First 2 lines, 1 string of text of regular text on the third line. Okay. So if we switch back now here, you can see that we're basically providing an image. That could be something dynamic that's coming in from your data. I'm just hard coding it here. We're setting some of the text to be dynamic here. The first line we're just going to say, make it the item text of the insert we're doing. And then you've got some other text for the last item. But the key thing to take away really is this is a really simple API. It's a few configuration steps. I'll show you how easy that is in VS 2013 if you're at the next session. But it really makes it easy to do. I've written a lot of notification stuff and libraries for this prior to mobile services coming out, and it does take quite a lot of time to deal with that. Basically, auth against WNS, take the auth token, dump it into a header on your HTTP request, and then post your XML with appropriate tags for WNS. And this makes it 1 line of code. I love it. What about the guy that did toasts before? Is this cool?
Well, I saw that question because currently I get confused with the notification hub.
Yep.
So to me, if you have an endpoint, it's already configured. I can still talk to it straight away. I can just basically bypass the notification hub. However, as Microsoft introduced notification hub, it's become part of the service. So my question is, that Wings is part of notification hub or it's not?
Is WNS? No.
Now is it?
No, so at the moment you're managing your own channels, etc. Notification Hubs does that for you.
So Notification Hub
Yep.
is purely an Azure Service Bus.
Notification Hub is purely an Azure Service Bus. Sort of. There's a lot more built to it around the push scenario to go and track your channels, deal with expired channels, deal with the HTTP response coming back from WNS. So it does a lot of things.
Another question is that like APNS, do you have some best practice in place? For example, DCF has restriction of hands-on request per die.
Yep.
They restrict from the receipt of the message down to the receipt.
Yep.
Does Wings have sort of limitation? And how these notification hub handle those kind of thresholds?
Notification hubs will just basically fire your notification, in that case, to, was it GCM or Apple that you're talking about? But in any case, you know, if you try to send 20,000, it's just going to try and do that. Yeah. So, but there is some logic built within it. Notification hubs, that is, not push.wns, for instance, but within notification hubs to look at those responses that are coming back. So in that case, it's probably going to log an error. Any limitations with the threshold? Let's shelve this and talk about notification hubs afterwards. I can't sort of go in too much depth here on that. So perform an insert, you can see, ta-da, there's a toast, right? Pretty cool. So using the same namespace, you could send tile updates and that kind of thing as well. We won't do a tile update. I think we need to keep moving here. All right. So, custom API. Custom API, so we just saw that server-side scripts on tables are typically tied to a CRUD operation. You don't really always want to execute script, you know, when you're performing an insert or an update or whatnot. For instance, the gentleman that asked earlier, can I call that from a website? You could call that from a website, but if you wanted to say provide an endpoint that anything can invoke over HTTP to send a notification, you'd use custom API. So that's what custom API. So basically, we provide all the REST HTTP verbs there, and you can set permissions for each of those verbs as well, similar to tables. I'll demonstrate that in the later session today. It's a bit too much content to get all in at once. So let's look at the scheduler, because this is sort of useful for a lot of application scenarios. Basically, it allows you to execute script on a schedule. So nothing has to hit an API to execute that script. So you may say you want it to run every 15 minutes. Really useful for things like going out and aggregating, say, news or weather and those types of things. So what we'll do here is we'll create a scheduled job, and I will hit the RSS feed for my blog and send a tile update, perhaps. So let's look at how that's done. Again, within the portal, if you go up to the top level here, select Scheduler, create a scheduled job. We can call this check feed. In terms of options, as far as how frequently this runs, you can like go to hours, days, and months. We're going to go 15 minutes. Let's set it to on-demand to start with. On-demand basically means you manually hit run once. I use that while I'm like developing out the script such that, you know, it's not going to try and run my script every 15 minutes. Otherwise, you know, you may have saved something and it's not quite right yet. So this will create our scheduled job. We can click into it. We can later change the schedule here once we're done, and we'll do that. So let's hit script. So let's run this. So this is just the basic baked-in hello world, I guess you could say. It used console.log. This is where we log anything that you're doing in your script. So you can log it as info, a warning in this case, or an error. Very useful if you're trying to debug these scripts, right? Because you're not running it locally with, you know, an F5 experience. So certainly worth paying attention to. So let's go to check feed here, and let's drop in some script. And I think I created a snippet here. This one. All right, there we go. How cool is that? It's a favorite that copies data to your clipboard. Pretty tricky, right? It's much easier than going to Notepad. But in any case, the entry point to this scheduled job is check feed. Within that, we're calling get updates and notify. So this is how you can actually utilize modules that are shipped in the box. So in this case, we're requiring the request module, because we want to perform a HTTP request outbound to my blog. And we're also using XML2.js, because we want to take the XML that's returned back in that RSS feed and turn it into a nice object that we can go and utilize to, say, drill into particular properties and find what we're after. So we essentially perform a HTTP GET out to the endpoint here, the feed. On completion, we new up the parser. We pass in basically the XML that's been returned from the HTTP request. And then I extract out, in this case, the title of the blog, and then the title of the actual blog post. And, sorry, this is a URL to an image for the RSS feed. This is the title of the blog. And this one here is basically the title of the blog post. So you can see they come in here, and similar to what we did before, it's identical code here, but in this case we're sending a tile, wide, small image, and text to our client. So let me save that. That reminds me I did one thing here that I missed. So if you want to be sending wide tile updates in this case, your application needs to declare that it wants to receive wide tiles. And to do that, you actually have to provide a default logo for that wide tile. That basically just means that if the app is pinned, there's going to be a logo that just shows up until a notification is sent. So let's save this. Okay. And now we'll need to rerun this, because when you change the package manifest, that's going to invalidate my channel URI. Let's just do a toast here quickly, just to make sure that everything's still right. Okay, there's the toast. So now I've got a valid channel. Let's have a look at how we pin this. So this is Windows 8.1, the preview we released back at build. Where is my app? What was it called? Does anyone remember what it was? TechEd 2013 was the name. So we need to, is it pinned already? Nope. TechEd. There it is. Let's pin this to start. So now I've got it here. Let's move it across. And now that we've provided a default wide tile logo, we can essentially resize this to wide. Okay. So that's our default logo. So now what we want to do is we want to just execute this script. I'm going to use run once here, and then I'll show you how you can enable that schedule. If we come back, when it decides that it wants to update the tile, you can see that it's gone off, hit my RSS feed, pulled down an image, the title of the blog, and the blog post. So quite powerful, few lines of code. To enable a schedule on this, simply hit configure, set your schedule, and maybe I want it every 15 minutes, hit save, and now every time I've got a new post, you're going to see an updated tile, which is pretty easy. So let's switch back. I think we've got a few other things to get through here.
How different is it now from the mobile experience? Because there was now the Windows.
Yeah.
How different would that be?
Yeah.
Same service in the background.
Yeah, sort of. Not really, actually. So Windows Phone, the service that it uses is called MPNS. WNS is what's used for Windows Store apps. So the actual code is a little bit similar, but you'd be doing a push.mpns.function name. Now, you may say, well, how do I know which is a channel for a phone and which one is for Windows Store? Essentially what you do there is when you upload the channel, you add a new property to your channel, DTO, called device type, for instance, and you just pass up, say, WinPhone or Win8. Then as you're iterating through the channels, you check the device type and call the appropriate method. MPNS doesn't require authenticated users for sending push, so it's a bit easier to implement. If you want to go over 500 per subscription per day, you need to essentially use a certificate. So that being said, let's talk quickly about this and then wrap up. So diagnostics, logging, and scale. We've got API calls, devices, and egress, so data going out of the data center. We log that. You can see some nice graphs of it. You can scale your service based off API calls. So mobile services now supports auto-scale, as do a lot of our other services. It's a recent thing we released about a month to 2 months ago, the capability to automatically scale out your solutions. Mobile services will scale out if you've got it configured to auto-scale based on how many API calls are coming in. Console logging from scripts, we saw that today, and you can also scale your DB. So if you started with a 1 gig DB, you could actually ramp that up to say, you know, a 5 gig, 10 gig, 20, 150 gig DB if you wanted to. So let's have a look here. So the tiers in terms of what mobile services provides. The free tier, you can have up to 500K API calls per subscription per month. So subscription in this sense means your Windows Azure subscription. So realistically, that provides you quite a lot of flexibility in terms of building an app, seeing if it's going to sink or swim with no cost. Standard tier, 1.5 million, premium, 15 million per month per unit. So a unit is essentially an instance. If you scale up from 1 to 2, you obviously get double. So in the premium case, you'd have 30 million API calls available to you per month. So let's have a quick look at where this stuff is in the portal. Okay, you got it. So let's go to our dashboard here. Let's see the diagnostics. So you can see here, we've got a couple graphs on here, API calls and data out in this case. You can add more. Where did they go? Must be over in configure there. We won't do that now, but basically API calls, data out. What was the last one that should be there? I can't even remember. Sorry. A little bit fried. It's 9:50 p.m. So that's our diagnostics. We saw logging. Let's look at scale. That's cool. So to scale this out, let's say it is getting quite popular, your service, it's really quite straightforward. Click a button. In this case, I'm scaling out to 1 instance on standard. Hit OK, hit yes, and then by the time this save dialog goes away, it's already up and running on, in this case, it's gone from a free, which is basically shared core, to a standard, which is a dedicated core for your particular service. If you want to scale up, hit save, and simply with that, we're now across 3 dedicated cores in the standard tier. So it's quite fast and easy to do. Auto scale essentially means that you don't have to come in here and press the buttons to scale this up and down. So if I wanted to auto scale this particular service, you can set a minimum range, minimum number of instances, and a maximum number of instances. And then based on how many API calls a day are hitting that particular service, it'll determine if you're hitting the limit, which is like 30 divided by 1.5 or 15 million, depending on what tier you're in, it'll go off and add another instance for you. At the end of the day, it'll actually pull them down as necessary. So basically, it reduces your cost because you're only scaling out as you sort of need that throughput. So I won't scale it out. So let's jump into the deck here. So there are a few things here that you should be aware of. So in the free tier, and it doesn't have it on there, in the free tier, you're actually limited in the number of devices that can actually connect to that service. I'm going to show you that because that's an important thing to know. So whilst you get, in this case, the 500K API calls, you will get throttled in the sense of if you have too many devices connecting to that free mobile service. Just click in here. This was an update they made since I made the deck. So in this case, you can only have up to 500 active devices on that particular mobile service. But for many small business scenarios, even perhaps a medium business, 500 devices is not a problem. It's more when you have a consumer application that's extremely popular. Okay, so I think that is it. So let's wrap up. So we saw and basically describe what Windows Azure Mobile Services is. We went through the data persistence layer that we've got there. So in this case, Windows Azure SQL DB. We looked at push notifications. We did toast and tile updates to Windows Store apps. We looked at auth, and we used Twitter as our identity provider. We executed some server script to do things like send that toast notification or to perform validation. We scaled our service in a matter of seconds. We looked at across the logging and diagnostics capabilities. Really useful when you start deving. Not very, exciting to talk about logging, but it'll save you. And the scheduler for going and executing script on a schedule. So with that, basically the one resource you should remember is the second one there, windowsazure.com /mobile, or easier, aka.ms mobile services. From within there, you've got step-by-step guides of how to do all this sort of stuff. You've got links to videos that myself and some of my colleagues have gone and recorded, and they sort of break things down into like a 10-minute sort of unit of work that'll get you started really, really easily there. If you're interested in seeing how the client SDKs are actually built, you can go out to GitHub. The full source is available there, and you can go and look at it, download it, and do what you like. Win a Sculpt mouse. Complete your session evaluation. It's like, you could get something better, right? Maybe an Xbox One. But this is sort of cool. It's like the special one that's got the Windows button there now. Resources, lots of them. Track resources, they're the ones they make me put in. Thank you for coming. I'll be available for questions.